together. Usually the bigger mass is going to be the original. A lot of times the metastatic emboli or metastatic foci of neoplastic cells are much more or much less differentiated. They'll look uglier than the original tumor. So you just try to put it all together and figure it out, but sometimes it's not very clear. But most of the time you can. And usually it's because you have this huge tumor in one place and you have all these little tumors other places. But that's a very good question. But it's not like a histological thing that's for sure. You can say, oh, this is a metastatic site. But they usually are less. So if I see like 6 different tumors and I take a piece of all of them, the original is usually going to be a little more differentiated than the other ones. Any other questions? Thank you. Okay, so now we're just going to talk about how do the tumors do this. So an important attribute of metastatic cells is the ability to attach to, degrade, and penetrate the extracellular matrix. That's the only way they can get from one place to the other. The extracellular matrix is, you have the extracellular matrix of the basement membrane, and you have the extracellular matrix of the interstitial connective tissue. The basement membrane is what separates epithelial and endothelial cells from the interstitial connective tissue. Yeah, so here's the basement membrane of epithelium. I'm trying to find one in blood. Here's the basement membrane of the endothelial cells. So one way or the other, it's going, even if it started off in here and got in here, it's still going to have to breach the basement membrane. Okay. Basement membranes consist of type 4 collagen, laminin, and proteoglycans. Common one is heparin sulfate. Interstitial connective tissue consists of type 1 collagen, which is the most abundant thing in the interstitial connective tissue. It also has laminin. This is the glue, quote unquote, that binds the epithelial cells and the type 4 collagen. Proteoglycans is what retains water in tissues and maintains the normal shape of the connective tissue. It keeps your elasticity in your skin. And fibronectin is the major adhesion promoting protein of the interstitial connective tissue. And we're going to look at each of these things in the flow diagram. So the 4 mechanisms of invasion, which are, I got this from your, are you McGavin Zachary recommended or Roberts and Cotran for y'all? Probably McGavin and Zachary. Y'all not have your book? So McGavin and Zachary, so it started off with it was just Robbins and Cotran, that's the author of Pathologic Basis of Disease. I was just saying by their author name, I forget the name of the book, but that's a human pathology book. But then we got our own, which is very similar to the human, at least in the first part, the general pathology section, like chapters 1 through 7, because general pathology is general pathology. But then the later chapters, it's all about veterinary pathology. So if y'all are interested in pathology, I highly recommend you get McGavin and Zachary. Okay, so the 4 steps are dissociation of cells from one another, secretion of protein enzymes that locally degrade the matrix components, aberrant attachment of tumor cells to the matrix components, such as to laminin and fibronectin, and migration of the tumor into the degraded zone of the extracellular matrix. So dissociation, degradation, attachment, and migration. I put this in here because I just think it's important to know, at least be familiar with this complex, which is what's responsible for cell-to-cell adhesion. So have y'all heard of E-cadherin and beta-catenin? Mm-hmm. Okay. So I just wanted to kind of put this diagram up there. So essentially, in order for the cells to dissociate, this bond has to be broken. Okay. And a lot of times you can actually find mutations in like beta-catenin where it becomes nuclear, and it's a whole other story of beta-catenin associated with carcinogenesis. But just since we're talking about dissociation, I just wanted you to visualize this complex that holds the cells together. So this would be the E-cadherin molecule, the beta-catenin, and there are other catenins, but the two most common things you'll hear about is beta-catenin and E-cadherin. All right, so the first step is dissociation or loosening of the intracellular junctions. Okay. So these, what do you call these when you see them histologically?
Macular.
Desmosomes. Yeah. Huh?
Macular.
Okay. Yeah, so they dissociate. And they secrete proteolytic enzymes, such as type 4 collagenase, which is one of them, that breaks down the collagen within the either basement membrane or interstitial connective tissue. Plasminogen activator, tissue plasminogen activator also breaks down collagen. And then they attach. So you have receptors on the epithelial cells that attach to the fibronectin, and then they move. So they'll secrete autocrine motility factor they actually like crawl their way through, like a crab. Cancer. All right? So are we good on that? Dissociation, degradation, attachment, and migration. And that's it, I think.
Do the cells,
Yes.
the cells come back together once they, like, if one migrates, so they're like close up? Is it like?
Mm-hmm. And it's usually more than one. So yeah. They will. Or they'll just divide and make some more. But a lot of times within the vessels, like physiologically when you look under the microscope, in a vessel, sometimes you will just see one cell, but usually you see a cluster of cells. Particularly when it's epithelial cells, because epithelial cells like to stick together, even when they're neoplastic. That's one of their features. Okay.
So chemotherapy will target the basement membrane above? Or does it have anything to do with that?
Chemotherapy just targets the cells, but it targets everything. That's why chemotherapy is so damaging to people who have to undergo chemotherapy. So chemotherapy doesn't, there's a lot of advances where you do kind of target specific things, and it's more and more that I've read about where it's more targeted towards this cell type. But for the most part, it just kind of goes in and destroys everything.
Aren't you, have you heard anything about them deciding now that the actual individual host factors play a greater part than they originally anticipated?
Oh, yeah.
So the chemo really is, they're gonna, in the future, perhaps be able to individually tailor the chemotherapy, for the, because it's so host dependent.
Yeah, there's a lot of research that talks about the impact that the body's own tissues have on the growth of the neoplastic cells. So before it was just neoplastic cell, but you have, your tissues that the neoplastic cells are in, or the stroma that is secreting cytokines that may be actually what's more responsible for that tumor growing than the tumor. So yeah, there's a lot of that research. So I think, just as advances and time goes on, people learn more and more. Anti-inflammatories is now being considered a very important treatment modality for tumors, because just the inflammatory response that your body's doing to try to do good is making those tumor cells grow. So there's a lot of that. There's so much research. Somebody wants to go into cancer research, you will never be bored.
Sorry to take you back. Could you go back to this slide and explain what you were talking about?
Sure. Okay, so you have a complex which consists of catenin and cadherin. So you have a catenin-cadherin complex which is responsible basically for the desmosomes, keeping everything together.
Okay.
A lot of times, is that good? Or you
Yeah.
want to go?
Well, you can continue.
Okay.
I was wondering what the connection was.
Yes, a lot of times in neoplastic cells, you have aberrant beta-catenin, which instead of staying at the cytoplasmic membrane and connected to this, it becomes, what do you call it, nuclear translocation. Instead of saying there, it goes to the nucleus. So now you've lost this complex that holds it together, and the beta-catenin plays a role in cellular progression. So normally, beta-catenin is degraded by this, there's a whole name for it, but it's like a ubiquitin proteasome pathway. So in some neoplastic cells, you lose the ability to degrade, that's one thing. And so it's going to the nucleus, and it also acts as a transcription factor to promote progression. So it's like one of those double whammy things. So one, you lose it from here, so you don't have the complex needed to keep cells together. And beta-catenin particularly, and others, even the gamma-catenin, there's research on that, actually acts almost like a oncogene to make the tumor grow. Any other questions? Alright, so that's it for this one. So we'll take a 10-minute break and we'll go on